the live session so that each one of you will get to know all the details within the ESS. So first of all, let me share my screen. Is it visible? Hello, is the screen visible? Okay. Uh, so we will start with today's presentation. So first of all, ESS stands for the Electrical System Sheet. So the intention of asking you people to fill these sheets each and every team is that number one, we as a tech team should be familiar with your systems, subsystems, the components that you're using, and we according to those we can estimate, we can evaluate your complete system design and we'll estimate the safety of your system. And the second important thing which is kept into mind while designing this ESS sheet is that uh, the new as well as the old teams which have been participating in this event. The intention behind this ESS sheet is to make you all aware about the uh, uh, parameters of your electric powertrain, of your system, of your safety component, so that you are well aware of those parameters while uh, procuring them or evaluating them to be a part of your systems and subsystems. So when you this is a blank template which has been submitted to you through the forum, and this is the first page which starts with the introduction of the sheet. The submission deadline is 30th of November 2025. And we have a complete cycle that needs to be followed when we are dealing with the CSS. So in the introduction sheet, it comes with the institute name, team ID, captain name, captain contact number, electrical head, team IDs, mentor name. When you will fill your email ID, when you will fill your team ID, your automatic mentor name will appear. The two mentors that have been allotted. And this year we are having two track to system category. So the first one is less than 60 volts, and the other one is between 60 to 84 volts. As you might be well aware that we have increased the maximum voltage, applicable voltage in our system. So greater than or equal to 84 volts is the maximum limit for your battery voltage. So if according to that, there are two categories in those. So if you are following the previous one, uh, you will be in the first category, and if you are between 60 to 84 volts, you will be in the second category. So this is the index through which you can jump on to various sheets within this Excel. So first of all, we will dive into accumulator. So what I will do is we will go hands-on while filling these sheets side by side. So first of all is the most important element of your battery pack, that is cell. So the first specification is cell make slash model slash form factor. So for example, cell make. So there are generally two type of teams that are participating in Baha. One is the team that procures their battery from a vendor, a complete battery, and other is the team that built and assemble their own battery packs. So these both details, this all the details about cell and battery pack will be important for both those teams, because this will help you to evaluate what is your system actually based upon, and also will let us know that what is the scope covered in the complete event for the cell and the accumulator. So cell make, there can be any make of the cell. For example, let's say you have a cell that is of, let's say, back. Back is a Chinese company, or cattle CATL, or it may be some made up of Samsung, LG, whatever might be the make. Then comes the model number. So the teams that are building their own battery packs. So when they procure their cells, these cells come with a built-in model number, which is been described by the manufacturer. So if you want to look into the model number of the cell, you can refer to the data sheet of the cell. All the cell parameters which are included here, as well as model number form factors, will be included in that data sheet. So model number, let's say it's XYZ, and form factor. So form factor is something that defines the shape and size of your battery pack. For let's say I will search here uh, type of type of lithium cells. Lithium. So the form factors is this. Either it may be a cylindrical cell, it may be a prismatic cell, it may be a pouch cell, it may be a coin cell. So depending on which type of cells you are using for your battery, you can mention, let's say you are using cylindrical cells, cylindrical, and also in cylindrical you are using, let's say, a specific form factor such as 21700 or 18650. This all these details for the teams will be available at your vendor site, or else you can refer to the data sheets of these cells that are using the battery pack. Let's say the cell chemistry. So by the rules, we are all applicable to use only lithium ion type of chemistries. And within that lithium ion, there are also some types of chemistries, for example, LFP, lithium ferrophosphate, and NCA, NMCl, So let's say you are using nickel manganese cobalt, NMC, nickel manganese cobalt. This is NMC chemistry. Cell capacity, it is generally the amount of charge that is stored in your cells. For example, if you are using a if you are using a cylindrical 21700 cell, so that capacity will be around 5000 to 6000. So generally, these all are the values that I am including just for the sake of understanding. Uh, you should refer to your data sheets. You should contact your vendors to know these exact values for your ESS. For prismatic cell, this capacity might be quite high. For example, let's say 80 Ah, 60 Ah. Maximum voltage, it depends on the chemistry that you are using. So maximum voltage is the maximum amount of voltage of an individual cell. Uh, for example, we are using an NMC chemistry, so the maximum voltage might be around 4.1 or 4.2. Let's say it's 4.2 volt. Nominal is generally used to describe the cell characteristics. So for NMC chemistry, that might be around 3.6 volts. Minimum voltage, it is the dead voltage at which the SOC would be zero. So for example, in NMC chemistry, it is generally around 2.6 to 2.5. So these are the inbuilt characteristics of your cell. You don't have any control over these parameters. Maximum discharge current 30 seconds will be in ampere. So this is how much amount of output current you can provide. So this 30-second is just for the sake of understanding of you. Generally, maximum discharge current is generally defined by the is generally defined and for individual cell and might differ from cell to cell. So you can like mention whatever might be the maximum discharge current. Let's say my maximum discharge current of my cell is like say 4C. So 4C is 4 times the capacity of the cell. The capacity is 5Ah. So 5 into 4, that might be around 20. So my maximum discharge current will be around 20 amps. Duration might change. but you should consider it to be around 30 seconds as well. Maximum continuous discharge current is the amount of current which your cell can continuously like uh, provide in case of like you are operating your motor at rated conditions. So it may be around 5 or 6 amperes in this condition. Okay, the next is maximum peak charge current. Uh, oh, sorry. Continuous discharge current is like 5 amps. Okay, here there might be some issue. Uh, Maximum peak discharge current. Okay, we will solve this issue. Maximum discharge current. Uh, Maximum peak charge current is uh, uh, maximum current you can charge your battery up to. Let's say mine is 5 amps of current. So that will be 1 C of charge. This is 5 amps. Maximum continuous charge current. This is generally what we call as a fast charge in certain scenarios that you are charging up to 1 C or 2 C. So 2 C would be around 10, 1 C will be around 5. Maximum continuous charge current is generally the low amount of current that needs to charge your battery, let's say within 3, 4, 5 hours. That will lead to increase in the total charge of your battery pack. So let's say in my case it's around 3 amps. So the next parameter that we have with us is the internal resistance. So internal resistance or impedance, let's say, there are generally of two types. We have ACIR and DCIR. So both these types of internal resistance are like available in the cell data sheet. Or if you wish to measure the resistances of your cell, so generally there are two methods through which you can like measure this internal resistance. ACIR you can measure through a specific testing instrument through which you can pass a small amount of AC current at higher frequencies, and in output it will give you the ACIR of your cell. And DCIR is generally calculated based on the pulses of higher DC current within your cell. So let's say uh, you have 100% charge cell, and you try to like discharge those cells at higher pulse. Let's say if your cell is 5 Ah, you go up to 4C, like you discharge 20 amperes of current for a pulse of 10 seconds, 20, 20, 20, 20, 20. And then through that, you measure the voltage at that instance where current is maximum. And using the voltage Ohm's law, V is equals to IR, you can then calculate the DCIR of your cell. So in whatever conditions lower the resistance of your cell, the better are those cells. And internal resistance is mainly dependent on various uh, uh, variables. Let's say how much old your cell is, or at what temperature you are measurement. So this is a like dependent characteristic of an individual cell. So let's say I am using something of uh, 5 milliohms kind of internal resistance, or it might be lower than this also. Operating temperature is range which is being specified by the cell manufacturer such that it is safe to operate those cells within this given temperature. So let's say your temperature is 10 degrees Celsius to let's say 60 degrees Celsius. So this again, okay, well, correct. So you need to mention the uh, temperature limit you need to mention the temperature range as specified by your operating temperature. So vendor details, let's say I have procured it from someone called as uh, Genuine Power or something. So you just mention whatever vendors you are having, and if you have any contact details of those vendor, you can also specify it. The next segment is the BMS. So BMS, uh, uh, so BMS is generally a brain of your battery that manages and controls your battery and ensures a smooth operation of your battery pack without hampering the safety of the vehicle. So maximum continuous discharge current. So most of the parameters within your BMS are either set from the industry, or like you can specify those parameters as per your will or as per your specifications that you have built your battery pack around. So maximum discharge continuous current. So as you're well aware that we are restricting the power to 9 kilowatt electrical. So based on the voltage limits, uh, you can't exceed more than 180 amps. And if you're in category 2, 120 ampere of current is your limit. So make sure you put, you can like go lower than limits, no problem. But you can't exceed these limits. If you are found exceeding these limits, uh, that might lead to uh, disqualification or some other kind of stuff with your team. So make sure that you are limiting the power through currents, and you are using appropriate fuse, and your cutoffs for discharge and as well as currents are within the specified limit. Uh, so continuous discharge of your BMS might be something around that will help you to maneuver easily with that amount of current. Peak discharge current is something that you can like obtain uh, at an instance where you require instantaneous power, or you want maximum torque out of in the conditions such as acceleration or uh, suspension and traction events. So let's say your maximum continuous charge current of your battery pack is around uh, 70 amperes of, and your peak discharge current, let's say I'm using a first category system, so it will be around 170 amps to ensure that I will not exceed the limit of 180. And overcurrent protection will be at around 180 ampere. So if it exceeds 180 amperes of current, my BMS will shut it down in any house scenario to ensure that the power is restricted to 180 amps. Charging voltage, charging voltage is based on like your maximum amount of voltage that your battery allows. So if I'm using a battery pack that is made up of 14S configuration, so that will give me a charging voltage of 58.8 volts. But there is one thing, you can like set this voltage to a lower limits through your BMS, let's say 58 volts or 56 volts, so that you ensure your batteries are to ensure slow degradation of your batteries, so that it could last a longer cycles, total cycles, charge discharge cycles. For in my case, I will consider it 58.8 volts based on my specifications that I've built. Charging current will be the one that I put here. For example, my continuous charging is 3. I'm using a 12S 24P configuration. So 24 into 3, something that amount of current will be required if I want, or else I can like specify certain currents such as let's say 20 amps, 25 amps to ensure that I'm getting a higher amount of capacity. 25 ampere is my charge current. These are so all these parameters mentioned in the BMS section are those which are fed to your BMS either by you or by the manufacturer that builds your BMS. So you can refer to the BMS data sheets if you don't have knowledge about any of these parameters within your system. Overcharge detection voltage. Overcharge detection voltage is something uh, that will cut my battery off in case of over voltage. So overcharge detection is 58.8, so it won't exceed 58.8 volts. And overcharge detection for my cell. So this is for the battery pack, the complete battery. And if you are familiar, BMS monitors the individual series cell within your battery pack. So if your one series exceeds, let's say 4.2 volts, it will cut it off. In my case, this value might differ in your case. Either you can refer to that. And delay time is the amount of time it takes generally to initiate the cutoff. Generally, this time is microseconds or some kind of seconds. So you can refer to data sheets. In my case, let's say it's 1 second. Overcharge release voltage. So this is when your charging completes, your BMS cut it off, and then when you disconnect the charger or when your contactors are within or your MOSFETs are open within the cell, so your voltage goes back to a certain your charger acts as a load in that scenario, and your voltage decrease. So you might have observed that when you charge your battery and when you it's completely charged, you don't see a perfect higher voltage cutoff. Let's say your cutoff is 58.8 volts, but you will see generally around 58.1, 58.2 or something, 57.5. So what happens is due to suddenly there is some drop in the voltage at the end of your charge. So this is that voltage at which your charger like switch your contactor switches again switch off. So in my case it is generally 58 volts. So cell balance detection voltage uh, is a voltage uh, at which your BMS will start to balance your cells. For example, in my case, it is 50 volts. These are the values that you can set in your BMS. And delta is, let's say, 0.5 volts. So now what is this delta? So we have multiple series of cells connected in the battery pack, 1, 2, 3, 4, 5, up to whatever number within the voltage zones. So what happens is all those cells are not very identical to each other. They have their own characteristics. They have different internal resistances in the battery pack. So what happens during charging and discharge? The cell voltage are not the same for each series, each string of series. So there is some deviation within that cell. So what happens when we consider two string of cells that are like completely apart? One is the maximum the voltage it can reach, and one has got the minimum the voltage. So the difference that forms between this, now this is called as delta, voltage delta. So if you are having, let's say, 14S configuration, and your cell is around 4.2, so there might be some cells that have, some voltage might be 4 volts of individual cell. So there might be some cells that might have reached 4.2 volts. There might be some at 4.1 volts. There might be some at 3.9 volts. So the delta is the difference of the maximum and the minimum. So how much is the maximum cell at what voltage it is, and how much voltage is the minimum cell. So when you subtract, you will get that delta. And so generally, what BMS do it calculates this delta by measuring the voltage of the cell, and then it try to balance. Means what it does is try to push small amount of extra current within the cell to ensure that the cell are balanced and are maintained at equal voltages. Or else there are two type of balancing, if you might be aware of it, that is active and passive balancing. What Either it can take charge from one cell and push it into another, this active balancing, and other one is either it can drain the voltage, it can convert the energy into heat in passive balancing. So that uh, that when it will take to balance, it depends on this delta voltage. If it exceeds a certain amount of value, your balancing process will start with by your BMS within your battery pack. Cell balancing voltage again, when it releases back, when it stops rebalancing, it is generally at lower voltage. Let's say it's at 40 volts. And balancing current is a small amount of current, either active or passive. Let's say in my case, it's 1 ampere of current that is in balancing with. Under voltage is the minimum voltage that you need to cut off so that your battery is safe in operation. So this can be based on the lower limits of the cell, 2.5 or some 2.25. So let's say mine is 35 volts. You can like keep this is a variable like fluctuating variable within your decision. So till what level you need to adjust your battery voltages so that you can extract maximum amount of capacity from your battery pack, and also you do not go beyond the lower capacity of your cell. Under voltage of a cell, let's say it's 2.5 or something based on the limits. You can look into the datasheet, whatever. And delay time, it's 1 second as well. So short circuit is generally the current when you short both your positive and negative terminal without any resistance in between. Generally, short circuit currents are in terms of thousands, and thousand amps. Generally, higher current is fine. But considering our system to be a robust one and to ensure that within your limits, we generally advise you to keep it around 180 to 200 amperes so that both of your limits will be hit. So let's say I will keep it around 200 amps. Delay time again is one. And the release condition for a short circuit is something that is defined within your BMS. So if there is some short circuit and the BMS cut it's off, like it's off. So what is your condition so that you can uh, switch on those MOSFETs back again? So release conditions can be like there is some delay or there is some manual intervention within your battery pack. You need to switch some switches or something like that. So it depends on BMS to BMS what is the relay condition. Number of temperature sensors. So along with monitoring temperature and voltage, along with monitoring voltage and current, temperature sensor is something that your BMS monitors. So there can be any type of temperature sensor, thermocouple, thermistor, function. So you need to ensure that you have maximum number of temperature sensors within your BMS. Let's say in my case it's 5. Whatever might be the number of temperature sensors, you just need to mention that value. And what is the overcurrent protection of your limits? So based on my operating condition of my cell, as I told 60 till 60 degrees Celsius, my cells can perform are within the safe zone. So I will ensure to keep my protection limits well beneath these limits. So let's say in my case is 55. Circuit breaker. So in case of generally BMS fault, for example, the over voltage fault, under voltage fault, over current fault. So what are the circuit breakers that I'm using for faults? It may be contactors that are built within your battery pack, or it may be MOSFETs that are built within your battery. So generally, these are all switches, electronic switches that is there. Communication protocol is like you have a display in front of you, so how your display is communicating, or you have some external device that is connected to your BMS. So how you are connecting that device. So let's say I'm using CAN protocol or having Bluetooth protocol. You need to mention this, or if you don't have any, you just get an NF not available. You can mention your vendor details if you have any. Okay, so battery pack assembly. Uh, so either you are building your own, you are assembling your own, or you have certain vendors for that. You can just click on the drop down and you can like fill that details on your own. So let's say mine is self assembled. Make will be mine. So it is self assembled. Model number and serial number. This will be NA in my case because what has happened because I have built my own battery pack. So if you want, you can give certain model number or serial number for your battery pack. Or else if you are using a certain vendor, so vendor specifies certain model number and serial number to each of the battery pack they measure. So you just need to ask your vendor for that number. Series configuration is number of cells connected in series. So in my case, it will be around 14s. So 14s is like 14 cells connected in series, and parallel configuration is connected in parallel. So series configuration is like positive terminal of one cell is connected to the negative terminal of other cells. So you like series connect in parallel, like terminals are connected to each other. Series you add up the voltage. In parallel you add up the current capacity AH. So 14s and let's say it's 24P. So 24 cells are connected in parallel configuration. And if you multiply 14 by 24, you will get the total number of cells that are used within your battery packs. As I showed you, maximum voltage is 58. So these are all auto-generated results. You don't need to put in values. You just need to select the configuration in parallel and series. And based on your values of your cell, you will get your maximum voltage. In my case, it's 58.8, correct. Nominal voltage is 50.4, correct. Minimum voltage is 35, that is again correct. Nominal capacity is 120 AH, that is also correct. Approximate weight, sorry. So you build your own battery packs and you weigh on your battery packs on a weighing scale. Uh, uh, yeah, you can measure the weight of your battery packs on a weighing scale. Or else you can ask your vendors for your battery pack. Let's say mine is 50 kg. Dimension, you can mention the dimension of your battery pack in mm. Let's say the length of the battery is around 500 by 500 by 500. So, this is just raw value. You can like measure the battery dimensions yourself. Maximum discharge current, uh, based on your cell, you can like mention where maximum is 40 hours. Continuous is like continuous was like 3 amps or something. So your continuous current will be 24 into 3, something around 70, 75, 78, 78 amps. Maximum interchange discharge current, it should not exceed 180. It should be less than 180 degrees, 180 amperes of current. Uh, in my case, it's around, I say, it is limited through BMS also. So maximum instantaneous will be something like around 125. Charge voltage, as I earlier told you, it is the maximum voltage of your battery pack or limited through your BMS. In my case, it's 58.8. Operating range, you can mention the range already mentioned above, 10 to 60, or you are limiting it to a higher temperature of 55. So you can mention that. Battery cooling, okay, battery cooling type, either your battery is air cooled, water cooled. You can mention that. Mine is air cooled. IP rating is generally required for your battery pack to be IP67. So by default, it should be IP67 for each and every teams. Battery casing material, uh, it may be uh, steel, it may be mild steel, it may be stainless steel, it may be aluminum, it may be titanium. You should ensure your battery casing material is rigid enough to conquer all the terrains of off-roading. HV connector type, either it is interlock based uh, or Anderson or something like that. Accumulator housing, so either you are manufacturing it or you are self-assembling it. You will just mention that, and then you need to mention details. And if you're building it on your own, it should be an charger, make and model, make, let's say since whatever it is, like हमारा राजा बैट हमारा राजा charger I'm using for my battery pack. Charging profile, general charging profile is CCCV. And if you are having some additional charging profiles for your custom profiles for your uh, battery pack, you can mention those profiles. At what power you are charging my battery? I'm charging at, let's say, it's 3 kilowatt. I'm charging output voltage, maximum voltage. I'm charging up to 58.8. Maximum input, it's 230 VAC. Input current, it's around 16 amps. So these two characteristics you will get on your charger. It will be mentioned on your charger. Maximum time for charge will be based on the amount of current you are charging with. So if you are charging with, let's say, 2C, so your charging time will be uh, zero point 0.5 hours. If you are charging with 1C, it will be 1 hour. Uh, Not exactly 1 hour, but close to 1 hour, because in CC and then you will be in CV. So it will be around 1 hour, 15 minutes or something like that. The lower the charging current, the higher will be charging current. So I'm charging with, let's say, zero point 0.5C. So not 0.5C. I'm charging with something around 0.25C or something. That might give me a 4 hour, 4 hours of charge. 4 hours into 60. You can mention that in minutes. And the vendor details that needs to be mentioned. So this year we are added another important thing, that is IMD, which is like an optional thing for you, but we highly encourage you teams to get acquainted with all these kinds of safety subsystems, so that when you will exceed with higher voltages greater than like, let's say, 100 volts or something like that, this kind of equipment will give an additional upper hand in safety or some kind of. Uh, so uh, yes or no, if you need to mention that, you need to mention make, model, serial number, and what is the installation resistance that you are monitoring up to, and at what level your error might be activated. You just need to mention that how much ohms per, let's say it's 500 ohms per volt, something like that. You need to mention that, and the vendor details. So this is done for first shift for the accumulator. Next is the motor controller. So number of motors that we are using in your vehicle, one, two, three, four, whatever might be the number of vehicles, we just need to mention that. Motor type, whatever we are using, PMSM, BLDC, induction, switch reluctance, synchronous reluctance, just mention that. Let's say I'm using PMSM. Number of phase, three phase, four phase, six phase, single phase. Uh, Generally, three phase type of motors are used for traction applications, so three phase. Make and model, make whatever might be the make of my motor. Let's say it's I'm using based on Dana, and whatever might be the model number of that. Operating voltage range. So this motor has certain operating range within your DC. So let's say, so use maximum amount. Mine. It is mentioned of your on your controller and motor that you buy. You will get the details of this operating voltage range within your system. So continuous power, this is the same thing that you can that generally a motor manufacturers provide you. Uh, let's say my continuous power is 4.5 kilowatt, and I get it at around uh, mm, let's say 2000 RPM. Maximum power should, in any case, should not exceed 9 kilowatt, because you are limited by your 9 kilowatt electrical. So it will be less than 9 kilowatt. Let's say mine is 8.2 kilowatt. And at what speed I'm getting it? I'm getting it at around 2500 RPM or something like that. Rated speed will be generally uh, the speed at which your motors operate till constant torque mode. And getting this 100, 1000. So, so there are two modes, as I've mentioned, specified in my previous seminars. You might be aware of that. So rated speed is generally at which you are uh, uh, it is a continuous operation of your vehicle. So let's say it's around 1000, and the maximum will go it up So 3700. So this is the maximum speed your motor can rev up to with the same controller, and this is the rated speed. You will get all these specifications in your motor sheet, data sheet. Continuous rated torque Newton meter. You can like measure the exact values at what is your maximum torque. Let's say my maximum torque is around 48 Newton meter, and I get it at 500 RPM. Continuous torque will be something around 12 watts. Continuous rated, it may be around like 3,000. So all these are like rough values. So if you are selecting certain motors for you, these all are the specifications of those motors. So there is 100% guarantee you would get these parameters of your motor in your data sheet. And if you don't have these parameters, I will also tell you how you can like measure this kind of details by performing certain experiments on your with certain equipment, and then you can like mention those values at the end. I will tell you. So cooling type, let's say I'm using an air cooled motor. Cooling system is powered by, so I'm using a passive air cooled, so it is not powered by something. So it will be an speed measurement, Hall encoder, resolver. Let's say my motor has an encoder. Control method, at what control you are using. So there are two types of control methods for that: speed control and torque control. So generally, traction motors are being operated in torque control. You can ask your vendors regarding if you have any doubt regarding this. Age of motor, you need to mention based on how much old it is. Operating temperature of motor is generally way higher than your battery pack, so it will be something around. Yeah, these limits are generally determined by the type of insulation. Let's say J class insulation, H class insulation, that and the magnet that you're using within your motor, the manufacturer is using. So it is generally like 10 degree to 150, 10 degrees Celsius to 150 degrees Celsius or something like that. And vendor details, you can mention the details of the vendors that you have got. So if you are increasing the number of motors within there, so you will get the same specification sheet again. If you are using two different motors or four different motors for you, so you can see here like I'm having four different so system with separate LV source used for motor control activation. Yes, if you have a separate, or if you are using a 12 volt system to operate your motors back to power them with that. Uh, so same here, you are using a motor controller. So you need to mention the control motor controller details as well. Let's say I'm using just a one motor, so will be one controller. Make an available battery voltage based on the initial voltage that I set. That will be 35 to 58.8. Sorry, 58.8. This is available motor power. That will be around 7.8 maximum available power. Peak phase currents, these are being defined on your motor constant or the maximum amount of current your controller can push. Let's say in my case, it's 250 RMS of current. So this is maximum phase current. Don't get confused it with the DC current. This is generally a three-phase current that is provided by a motor controller. Your DC current is converted in three-phase in this motor controller, and you need to mention the maximum phase current for that. So this is an important parameter that you should mention. Maximum rated DC current will be something around that I mentioned for the bat controller. Maximum DC ampere, it should be always less than 180 for first and 125 for second category. Communication protocol again can something like that. Throttle type, input is based on what throttle you are using. Either you are using, let's say, uh, potentiometer, potentiometer, or you are using Hall effect, or else you are using drive by wire system. In that you are using CAN command. to control the throttle of your vehicle. So you can also send. So this is throttle by wire system. Operating temperature range, you will get that range, and then you need to mention the vendor details in that. If you are using an auxiliary battery to power your controller, you just need to mention that, or you are using a DC-DC, or rather if you are using nothing, just to know. Auxiliary battery, it is the specifications are same as uh, more or less same as that of your main battery. So lead acid and lead. So there are certain more parameters for lithium ion. You just need to add those. So we will not discuss this in detail, but uh, you will have a good understanding of these ideas based on the accumulator, the main accumulator of your battery. So all those parameters are nearby, like equivalent for that. So you need to refer to the auxiliary batteries you're using and fill those details appropriately. So this is safety component within your battery pack, and same here, make model, color should be amber, flash rate at what flash rate it is flashing, like say 1 hertz, 2 hertz, 2 to 5 hertz, it is mandatory as per the rule book. So you need to include that. There's one important thing that I told you, that if you just hover your specification, so if there is any instruction or note for you, it just appears on your screen. So if you have any doubt regarding that, you can refer to this note, and then appropriately you can fill those values, or you can like contact the respective person if you are having facing any doubt. Operating voltage, it should be less than your lower voltage. It should be less than your maximum voltage of your auxiliary battery or your contactor, or your DC-DC converter, something. IP rating is whatever might be the IP for that. IP is ingress protection. Same with ready to drive sound. Sound intensity, you need to measure that and mention control voltage, what is the voltage for that and all that. So you have this fuse to like uh, limit the current. So you need to mention the current limits based on the fuse that you're using within the system to limit the power at both controller level and also at the battery level if you have any fuse within. AIR is accumulator isolation relay, that are your contactors that is used to on and off your uh, high voltage source, high voltage, high current source. So you just need to mention the make, model, contact current, current voltage, contact voltage. Contact voltage is the operating lower voltage that you provide as a signal to your contactor. So switch it on and switch it off, and also the type. Firewall, as per the rule, how much firewall you are using and what is the material for that, insulating material you are using for firewall. You need to mention that. Let's say I'm using thickness of something like 1, and my insulating material I'm using is Nomex to cover my firewall, metallic firewall. As per the mechanical rules, it should be compliant. Kill switch, kill to open, rotate to kill to switch, rotate to open type of switch. Number of kill switch mandatory to you can increase. You can like include more than this within your systems, and operating voltage 12 volt or something that like that of your auxiliary battery. Ignition switch also you need to mention the same. Same for the HV cutoff switch. Same for the reverse alarm. This is an interesting segment here. There is segments within your driver rule book. See 5.8.1, 5.8.2, and 5.8.4. So these rules have been mentioned in this yellow box here, uh, node box. So you need to make sure that all these things are incorporated in your driver display. Let's say you need to display the temperature, the voltage, the state of charge within your battery when it is turned on. Other is you should indicate there should be indication of LV and HV tractor system based on the lights, green light, red, yellow light. Another is display parameters should match to the real time of BMS. So your BMS might be monitoring the data and be displaying you at certain app through certain app or at your display. So you need to ensure that both the values are within the range of each other. Brake light, same with the electrical parameters. Brake light, reverse light. These are bare minimum. The color, white color. If your brake light is red color, whatever might be the make, Polaris something, Indian OEM. Operating voltage, lower operating voltage for that. any other light fusion system, and HV wire. HV wire, let's say HV wire should be of orange color. There is no exception to this to indicate it is binary. And gauge wire, it is dependent on how much current is your system. For example, I might be using something called as 4 AWG wire for my system or 6 AWG wire for my system based on the amount of current flowing through my system. Other next part is your LV system. So these are all the parameters for your DC-DC converter. Let's say mine is auxiliary battery that I am using. So these are the auxiliary battery details that you need to mention. That you have already mentioned, you just need to copy paste those readings over here in your lower system. And if you are using a DC-DC converter, these are all the parameters that you need to mention that are generally obtained through your DC spec sheet. So you should read your spec sheets carefully for DC controller converters, and you should use those for your. If you are using an additional 9-volt supply for your uh, uh, data system, you need to mention that details also. 9-volt battery for your, or you are using a DC converter for your data acquisition system, you need to mention those details. So these are generally like voltage, ampere, currents, all this kind of stuff for your uh, vehicle. Circuit diagrams. This your circuit diagrams should be descriptive very much so that it is when you take a look at the circuit diagrams, you are easy to understand. It should be highly readable, and it should be mess free. Means you should be clearly visible in all kind of sense. Uh, so BMS wiring diagram is generally based on how you are connecting your BMS, or how your BMS is connected to within your battery pack with all those cells, temperature measuring, current measuring, where are your current transformers or your Hall effect sensors to measure the or your shunt to measure the current in positive line, negative line, where are your contactor, where are your MOSFETs placed. So that should be included in VS wiring diagram. So this diagram is generally included in your BMS datasheet. So you can just copy paste that datasheet diagram. Circuit diagram, tractive circuit diagram, you should mention that diagram clearly. And circuit diagram for LV. So these are proper circuit diagrams that needs to be mentioned, ensuring each and every component is clearly visible within your diagram. And also the connections are well documented and well routed and arranged so that it is quite readable in that format. So you can just copy paste those diagrams directly here. So generally, we have a flow diagram. Let's say you are using a motor, then you have battery, and then battery is connected to a inverter converts into and sends it to motor transmits through a gearbox to your differential or your wheels through propeller shaft, axle, and then accelerator. So you need to document proper flow diagram for that, and you need to mention. Let's say you are using a uh, two motor setup for your front and rear wheel in your four-wheel drive system. So you need to show exactly how your power is being segregated from your one battery to your multiple controllers, and you need to document that properly here. You need to paste the actual pictures. You need to click with your phone, and you need to put for HV and LV wiring harness. So what you can do is you can to make it more appropriate. You can remove the mechanical components from your vehicle. Let's say your wheel hub, your seats, your this steering, and all those. And you can just take a picture of your roll cage with all the electrical components mounted and proper wiring being routed as per your final vehicle configuration, and then you can paste that images here so that we as a tech team would get a brief understanding about how you are routing your cables, and is it safe to do, and we will evaluate you based on that. So battery pack picture images, you can post the external pictures of your battery pack and the pictures of your custom electrical components like T-cell, LV battery, and all this. And this segment you need to describe how you are building to plan up your startup sequence. So what is your electrical designs, which signals you are monitoring, which parameters, what logic you have incorporated, what hardware you are using. So you need to describe that hardware properly. What is your logic for that, and at end how you will how will your system will be done. For let's say I'm using a certain controller to monitor certain values. For example, I'm valuing my kill switch signal, ignition signal, and when that all is on, then I'm monitoring my start stop button signal, and based on that I am developing a logic. Let's say if all my signals are active and healthy to go, and when my pedal is pressed, I will take that signal, a 12-volt 5-volt signal, and then I will read it. And then how means the complete process that you will be incorporating, that needs to be detailedly, you need to detail instructions of your startup as well as hardware, and all those uh, systems should be mentioned in this segment. So graphs is important topic that needs to be covered. So the first one is the power characteristics of your graph. So I will show you one graph for your reference, and you should be based on. So what we call is this torque speed curve. Torque speed curve. Okay. So this is the torque speed that I'm talking. So the blue one is torque. So you can see you can maintain constant torque at certain RPM, and then your torque drop to decrease. So these are y-axis, primary, secondary, and your x-axis your speed. So you can so these charts are mentioned with your motor and your controller, so that you can directly measure torque speed curve at your end. And if you don't have this kind of graphs available at your end, what you can do is you can mount your motor and controller on a dynamometer, and then you can measure the torque and power at particular RPM and particular voltage for that. So then you can measure the maximum torque, and then eventually you can calculate the power by using formula 2.60, and then you can map this torque speed curve. It not might be exactly like this, but certain kind of torque, it is like you will have constant torque up to certain region, and then your torque will stop. This is the field weakening zone. Then, and in the same instance your power will be increasing, but when you hit the maximum torque point, then your power will decrease, or it will stay constant, as you can see in this curve. So more or less, this is a torque speed curve for your induction motors, how it looks. uh, so this top speed curves you generally get in your motor manufacturer template, or your data sheet, or your manufacturing sheet that is provided by your manufacturer. So you can paste that here. Another is this motor speed, torque versus motor current. So in this, what you need to do is you need to plot your motor speed or current based on the maximum torque of your motor. So this will be peak motor torque. So how much AC current it is consuming for that, and what will be the speed at that point. So this you can calculate. Same you can calculate on dynamometer, but one extra instrument you will require is that you will require a power analyzer, or a power meter, or let's say you have certain clamp meters to measure the current, phase currents of your ARMS, uh, root mean square current of your motor. So you can plot that motor characteristic here. And at the end, this is brief based on what you have incorporated within your system, that will be included here. Forward drive, wheel drive. You need to select the parameters appropriately. Combined shaft power, 8.2 kilowatt based on certain things. And how you will calculate the range. So let's say, for example, you are using certain simulation software, let's say MATLAB, IPG. So what you need to build certain drive cycles for that. What is drive cycle? Drive cycle is your velocity versus speed graph, velocity versus time graph. So you need to put in your vehicle parameters, and you need to create some maps accordingly that, and then you need to mention this condition that at every point my speed should be 40 kilometers. and then you need to mention at what one particular full charge, 100% SSD, what is the range obtained. So let's say mine range is something that I have calculated in my simulation, it comes around 52. And then the same simulation, you need to mention your Indian drive cycle. So now what is Indian drive cycle? Indian drive cycle is being generated so that we simulate a complete drive cycle as per Indian scenario. So if you want, you can search on Google Indian drive cycle. So this is 108-second drive cycle, which is velocity versus time for our general route. So these are used to quantify the complete range of vehicles. If you study automobile engineering to a larger extent, you will see that the range of these electric vehicles and the mileage of your vehicles are generally calculated not based on the real driving scenarios, but based on these drive cycles. So what it has been done is we generally run the motor, run the vehicle, run the bikes, cars at these particular speed profiles, and then we calculate how much mileage your vehicle is generating when following these drive cycles at continuous loop, one by one by one by one. So generally, this Indian drive cycle maximum speed is around 42, and approximate based on for effective calculation of that particular instance. So you can like mention the drive cycle, which might be quite higher in this scenario. It may be something around 70 or 60 something. Now, actually, what you can to measure the actual range of your vehicle, you need to derive a certain patch, circular patch, straight patch, and that you need to mention 40 kilometers, approximately, not with exact 40, but you need to maintain 40 kilometers in per work day, and you need to measure the range of your vehicle. Let's say your is is somewhere around 49 to 50 or something, and you and as a student level, it will be very difficult for you to maintain Indian drive cycle and actual scenario. So what you can mention is you can like drive your vehicle on a certain appropriate patch, which includes your obstacles, high speed patch, corners, and all the things. And then you can mention the range of your vehicle. So let's in that scenario, your range comes out to be around 45. So in actual scenario, your range will be less as compared to the simulation based on that. Uh, so same, you need to mention all your details based on your actual and your simulation weight. So the maximum vehicle speed in your simulation speed is 1360 as per the limits, but in actual you are getting due to your motor limits or something like transmit due to you are achieving something around 59, 58 kilometers of speed based on yes. So maximum acceleration that you have simulated in your IPG is something around 4 meter per second square, but in actually you are getting just 2.9 or 2.8 something like that. Average acceleration of vehicle from 0 to 40. So you can calculate and also you can validate the same on your vehicle. Braking distance 40 kilometers to 0. Let's say in simulation you are meeting the mark of 8 meter, but in simulation you are getting around 7 or something like that. In actual, you are getting around 8 meters or something like that, based on your uh, brake calculations and all those things. Braking time it takes 2 seconds, 3 seconds, 4 seconds, whatever might be the time. Current drawn. This is the current DC current from accumulator at starting. At starting will be your inrush current, and then at 15, 20 kilometers you can measure it with the help of your BMS, or you can install a certain clamp meter to measure the current. Uh, what are your current at simulation based in your MATLAB, IPG, or something like that, and then actual what we're doing. And then you can mention the vehicle weight, your design weight, your actual weight, and gradability. Gradability will be in terms of percent. How much gradability you are achieving, 75%, 40%, 50, 60, 70, 80, 90%. So 100% gradability is like 45 degrees. So based on that, you can calculate the gradability in percentage. Swappable packs, if you are using one pack, it will be no for swapping. But you have more than that, you need to mention you are using 4 packs, 3 packs, then you need to mention the swapping will be yes. And if you are implementing regeneration, you need to mention that also. if you are including regeneration. Regeneration is like when you are braking or stopping your vehicle, so your motor will act as a generator and it will push back current in your battery. So what will be the maximum kilowatt based on your braking, 100% braking, 50% regen, 50. So you can like calculate. You can these values have been mentioned in your motor controller data sheet, so you can refer to that value also. Certificates, you need to, it is mandatory for you to give us a AS 156 certificates if you're buying it from a certain vendor. You can paste the Google link or you can attach the PDF copy for that datasheet. It might be an AS 156 datasheet from certain agencies such as ICAT, ARAI, or some any other agency. So if you want to see if, what is generally in that AS 156 document, you can just uh, go to AIS 156 document, and from ARI website or certain, or you can like download the 156 document. So I will show you what it generally looks like. Here you can download AIS. AIS 156 is generally based for L LNM category vehicles. So those are two-wheelers and three-wheelers. Uh, that the battery pack is very small as compared to that used for the four-wheeler. 156, 156, 156. Yeah. So there are certain amendments made to this 156 as 156. So if you want to read this document, I encourage you all to read this document and let me know. You can approach me on my LinkedIn or something. I will guide you to what all these things are, so that you can increase your knowledge based on the certification activities are also part of your battery testing and all this kind of stuff. So this include all your tests from electrical test, mechanical test, thermal test. So these tests are performed on your vehicle, and these are both your let's say destructive and non-destructive tests are included in this. This will ensure your battery packs are built up to the standards and are safe to be operated on the roads for your vehicles. So you can read these documents and you can like uh, perform certain tests if you want on an individual level for yourself. The non-destructive test can be performed. So you need to copy paste the link. So your vendor will provide you with a document for this. If you are using a if you are using a battery pack from your vendor, you need to mention the Google link drive or attach the PDF for that. And IP67 is generally a certificate that is provided by the manufacturer. So you need to do the same thing with your, or else there is one IP67 testing SOP being released on the forum. So you can perform your IP61 test as per that forum, and you can like paste you can attach the videos and this along with the declaration from the college from your side. Same with the motor controller. For battery motor controller contactor, all the details have been mentioned in that datasheet. And you can specify the motor datasheet, sales datasheet. You can attach it, or you can paste the link for all the systems that you're using within your for your system systems. Uh, uh, and the whole motto of this session was to make sure that you get you know all those parameters, what are those parameters, how they are used, where you can refer to those parameters, so that you will make minimum number of mistakes while completing your ESS. We are not expecting you to like exactly make zero mistakes, but this will reduce, it will provide us uh, it will require us less time to complete the evaluation of sheets, and then we can provide you the feedback with as soon as possible. So you need to be extra cautious when filling the CSS, and as per the sessions that are conducted, you can like refer to those values for your reference, or you can ask your mentors if you have certain doubts regarding that. So we will stop this sharing, and now we will refer to certain doubts that you guys have regarding ESS. Any questions, any queries? Mention in the chat. Okay.
Hello, sir, am I audible?
Yes, you are audible.
Yes, within the cooling part of motors,
Yes.
the cooling type that has to be mentioned. I've tried mentioning natural convection, but it is still showing error, and it's not changing from air cooled. I don't understand why is that happening.
Uh, Sorry, I didn't got your point. Could you please repeat?
Actually, within the motor cooling type, because the clause is given that it should be either natural convection or to liquid cooling, right?
Uh,
As
I'm
I
really,
type in,
excuse me.
I
I'm
type
really
the
sorry. I'm not able to hear what you are trying to say. Could you please just write in the chat box? We'll have a quick look. All of the teams, all of the anyone who have queries, you can mention those queries within the chat box. We'll try to address important and as many as queries as possible within the given time. So we have one more announcement from tech team to be made for you. Uh, there is a skip the queue provision during the electrical TI only. If you clear the ESS in first attempt. So this is an important thing that you should keep in mind. So with the actual validity that you are, the correctness which we are performing your ESS will be very helpful for you in your TI. You can use the skip the queue means you can skip the queue if you will fill correct ESS in your first attempt, evaluated ESS. So you can access the skip the queue feature during the event. That will be only for electrical TI. Okay, we have first query. Is there any validity for AI certificates? We have conducted test for it last year. Will it work this year as well? So AIS, there is no validity for AI certificates. As long as you are using the same part number, model number, same specification battery that have been tested, that will be validated. That will be valid for the event as well. Cooling type of motor is not accepting natural convection. Okay, so natural convection will be based on the air that you are using. You are not using fan. So I would suggest you just put in air cooling for that. In motor controls is available battery voltage, available motor power. We have to keep nominal voltage, power. You need to keep the peak voltage in that scenario, peak voltage per power. In cooling part of the motor, we can't be able to fill the liquid. I can't be able to fill anything. It's showing error. Please, the cooling system such as force cooling, liquid cooling, natural convection. Self condenser, the maximum continuous charge when enters in the system. Yeah, there is some issue with the date format. Changes to date format. We will try to uh, correct that issue.
cooling.
Since our period are not,
जसे जर आपला फर्स्ट प्रायमरी क्लिअर झालं ना तर लाईक ट्रायल्स होतात जर तुमचं फर्स्ट टीचर सगळं करेक्ट नसेल ना तर तुमचं ESSC पण येते जर आपण फर्स्ट प्रायमरी क्लिअर झालं ना आपल्याकडे स्पेशल पेटच नाही क्लिअर TTL
could you
सेपरेट
please turn off your mind? Finals does that
Mhm.
mean IMD become compulsory? IMD is an optional thing. It is not compulsory for if you are opting. You just need to mention that thing. Is it possible to add regenerative rate after filling the
Yeah,
ESS?
separate
No, no.
from that.
We can add some
Maybe
additional
they are not.
features after. No, it is final. You can't make changes. So whatever details you are mentioning in the ESS are considered to be final. There is a note regarding that introduction page. Uh, every component listed in the ESS is regarded as final, and no further modifications are permitted for that ESS. So you are not allowed to make any modifications in the ESS. Can we have the maximum continuous current and the peak continuous current of the accumulator same? Yes, you can have if your thermals and your electrical design is suited. Your maximum current, yeah, your peak current can be your continuous current in that scenario. Okay, any more doubts? Can you explain the voltage delta part again? So voltage delta is something, as I told, your cells are connected in series, 1S, 2S, 3S, 14S. So these 14 cells have their own voltages. Let's say I'm using a 4.2 volt cell and that is charged at 4 volt. So there might be chances that all the cells are not exactly 4 volt. Some might be 4.05, some might be 4.2. So if I take the maximum voltage within that string and the minimum voltage within that string, I will come to know what is the delta, what is the total difference within the cell. So that is the delta part. That is the voltage delta of the individual cell. And based on that delta, your this what I say uh, balancing is being carried out. In the description of status sequence, you can add in terms of paragraph only. It needs to be quite descriptive. It can't be accumulated within the flowcharts. So I would suggest you add that in terms of paragraphs only. IMD is optional, as I told. If your BMS doesn't and you want to implement certain IMD device, you can use.
IMD 100%
Uh,
optional. IMD is attention something.
if motor is rated for higher kilowatt, then we should mention in the section of this for the manufacturing with higher kilowatt. If you are using a higher kilowatt motor, you need to cap that to 9 kilowatt electrical and then mention that maximum as a peak power of your motor. So do we have to do a battery test again if we are using last year like the vibration test and other things? If you are using the same battery pack, if you are custom build your battery pack and you're using same as you have used previous year, there is no need to do repeat the test mentioned in the test. And if you are doing any changes within that battery pack, for example, you have eliminated certain components, you have reduced the weight, or you have modified your battery pack, you need to perform those tests again. Can you show certain circuit diagrams to get an idea? Exactly, I don't have any kind of certain circuit diagrams here right now with me, but you can refer to circuit diagrams on the internet and you can use those diagrams as a reference and you can design your own diagram for that. Uh, so one thing that I mentioned about TI, so you can use skip the queue feature during electrical TI only if you clear the ESS in first attempt. So if your ESS is up to the mark and it is exceptionally well built and you are clearing your ESS in first attempt, you will get a feature of skip the queue and that will be only applicable to electrical TI, not the mechanical one. how can we get reference for gradability or how can we get actual value? So gradability reference is generally included based on your design. So when you do your traction calculations now, you assume certain gradability and then you use that in a certain formula to calculate the torque at certain gradients. So you can like fill that as an actual value. You can fill that in software. And if you need to evaluate your gradability, you can like uh, climb your vehicle on a steep slope at certain angles, and you try to figure out if your vehicle able to complete that track grade that, and that you can validate your system. But gradability is included in your design at the starting of the design. Is there any rule? This all these rules kind of stuff you can like find it in the rule book. So this is not the right place to discuss the rules. If you have any doubt regarding the ESS, we will counter those doubts. 3.03 fuse. So this fuse specifications you need to mention what is so you have your fuse in your battery pack in your controller. So it is a delay type instant blow, and what are the current ratings? It is 180 amps, 125 amps. What is the rated voltage for that? Let's say 58.8 volt, 48 volts. So you have to mention that. Fuse values are shown in complete this. Okay. Okay. So, and from test. Good question. Uh, so around something. So how will you come to know that your ESS has been approved in first attempt? There will be no feedback coming to you from the ESS from the tech team or from the Baha community as well. So in that scenario, you can be considered, or there might be something that we will push you, we will tell you to know that you have completed your TI in first attempt, ESS in first attempt, and what will be the IMD will be taken into consideration during the rainstorm. So okay, the rainstorm we will consider the values of insulation monitoring as per AS 156. That is just I will let you know the exact value for that. So if AC and DC buses are generally applicable, so it will be 100 ohms per volt for DC buses and 500 ohms per volt for your AC buses. So isolation monitoring, the IR that will measure that will be 100 ohms per volt for DC buses and 500 ohms per volt for your AC buses. Buses means AC lines. If vendor does not have given a circuit diagram, you can find that on the internet. Circuit diagrams for certain BMS can be found on it. To usually as auxiliary base during manual requirement for a capacity. No, if there is no requirement of current capacity on your auxiliary pack, you need to do your auxiliary load calculations, and based on that, you need to find the exact capacity of your skipping the line will be allowed during TI changes. We will this skip the queue line now. We will release a perfect guideline for that and what scenarios you can use it. I just told you just to make sure I intimated you regarding the skip the queue, so that you will maintain the ESS properly in first attempt. A perfect detailed guideline for skipping the queue will be released in the coming time for you all. Uh, you can read the there is no fixed amount of attempts that you need to take to complete the ESS as per my knowledge. But based on the first feedback only, you should like minimum should be one time you need to, so that we can reduce the time. You should try to complete in first attempt, and if it's not possible in second attempt, the mentor will tell you certain things, and you need to correct those things back. Okay, fine. That will be all for this event. Uh, I hope I have cleared all your doubts. I hope you will submit the correct TSS in the very first attempt and will use the rules applicable, skip the rule. And we will meet in the event. We will refer to the TSS sheet and make sure that your TI and inspection will go as smooth as possible, and you will be able to clear your TI also in first attempt, and you will be able to participate in the dynamic events with all this kind of stuff. Okay, thank you.